Hello and welcome to this in-depth, step-by-step look at how to use the Haas Tool Presetter, the HTS400. Now if this is your first time hearing about the HTS400, I made an earlier video where I go over how the presetter works and why it's beneficial for you to have in your shop. So if you haven't seen that, I highly recommend you watching that video first and then coming back to this one afterwards. Now this is going to be a rather long video, so there are time codes for all the sections that I'm going to cover for you to reference throughout the video. And you can also find them in the description below. So with that said, let's get into it. Now there are a few steps you want to do before you begin using your presetter. First, make sure that the whip system is properly set up on your machine. This is important because we want the tool measurement that we get on our presetter to match the one that we would get on our machine. Now if you've never set up the whip system on your machine or simply want to verify that it was set up properly, John Nelson made a great video detailing this entire process, so you can check that out in the link in the description below. So when calibrating the tool probe, you are required to use a calibration tool, which is simply a tool of a known length. Now you can make your own tool or you can buy your own calibration tool. Both work fine. Now whichever tool you use, make sure that you hold on to it, as later on you will need the length value that you entered into the machine when calibrating the presetter. Next, you'll want to make sure that the correct tool sleeve is installed for whatever tool type you're going to be measuring. There are 40 taper, 50 taper, 30 taper, and HSK tool sleeves available, and each can be swapped out for each other if needed. Simply grab the handle of the tool sleeve and pull straight up to remove the sleeve. Lift the new sleeve by the same handle and slowly insert the tool sleeve into the bore on the presetter, making sure to keep the sleeve in line with the bore to avoid binding. And finally, it seems obvious, but make sure the unit is plugged in and turned on. Now when the presetter first starts up, you will be prompted to calibrate the X and Z axes. Now for anyone familiar with Haas machines, this is equivalent to homing the axes of the machine during a power-up restart. Release the lock on each axis and move the lens up and down and side to side until the red flashing lines in the axes readouts turn green. It is important that you only use the red handle to make these movements and never touch the lens. Once finished, you can close the calibration window, and if you haven't changed anything in the time since it was last shut down, you are good to use the presetter and measure tools. Now, in the case that you are using the unit for the first time, swapped out tool sleeves, or simply haven't used the presetter in a while, you're going to want to calibrate the master origin. On every tool sleeve, there is a calibration section with either a square or spherical edge used to set the X and Z origin. For example, on this 40 taper tool sleeve, I have a square calibration edge, so I'm going to make sure that I have fixed axis selected, and then I'm going to maneuver the lens until the crosshairs intersect with that calibration edge. To do this, I'm going to make sure that the axis locks are loose and move the lens into a rough position until the calibration edge is in view. Then I'm going to rotate the tool sleeve until the edge is in focus. This is the point where the edge is no longer blurry and has sharp edges along the tool profile. Once that is done, tighten both the axis locks and use the adjustment wheels to move the crosshairs into position. While you're doing this, you'll notice that there are two arrows that move as you get closer to the edge of the X and Z axis. These arrows let you know how close the crosshairs are to intersecting with the edge of the axis, with an arrow in the green zone being the most accurate. Once I've got the crosshairs in position, in the top right corner, I'm going to click on the X and Z calibration buttons. You'll notice that there is a value associated with each axis. These values are very important, as when I click on each button, the presetter will set my current position value to whatever I have in that field. Now in most cases, Z will always be 0. However, the X value will vary from sleeve to sleeve. Now before I calibrate the X axis, I'm going to verify that the value in the box matches the value engraved on the tool sleeve. If it doesn't match, you can change the value in the machine origins library by editing the master origin. Now since my values on screen both match up, I'm going to click both the X and Z calibration buttons, and then I'm all good to go. Now, calibrating the master origin ensured that the X and Z readouts that we get on our presetter are accurate. However, we can't measure tools until we create a machine origin. This is where we're going to use the calibration tool that we used earlier when calibrating our whip system. place the calibration tool in the tool sleeve and position the lens to measure the z-axis of the tool. Now, right off the bat, you'll notice that the values don't match up. But before you get concerned, this is expected, and I'll show you how to get those values to match in just a second. Leave the tool where it is and open up the Machine Origins library and select the plus button to create a new origin. Enter in the name of the origin, and since I'm going to be loading tools into my VF2YT, I'm going to be real creative and call this origin VF2YT. Next, I'm going to designate whether I'm going to record the values of my tools in diameter or radius. We recommend diameter if you have an NGC control. Next, enter in the height of the calibration tool, which should be the same value that you entered in when calibrating the whip system on your machine. Once you've done that, you should notice that the DZ field gets automatically filled in. Do not change this value. This is the value that ensures that the measurements on the presetter actually match the machine. Next, enter in the max number of tools allowed for this origin. If you leave it blank, it will just default to 999. Next, open Elaboration and select the post-processor you would like to use for this origin. Since I have an NGC mill, I'm going to select the first one. Next, open Exportation and select how to export the file. When I export files, I want to go to my USB, so I will select that one. Next, I'm going to select the button with the CNC on it to choose the image I would like to help identify this origin from some of the other origins I'm going to create. So since I have a VF2YT, I'm going to choose that one. Once I'm done, I'm going to click the green check mark. Now, you'll notice that the z-axis values are correct, and this is all due to that DZ value. You can follow this same process again to create additional origins for other machines, or even separate tools by taper type. All right, with our origin created, now we can finally measure some tools. So let's begin by measuring this 3/4 inch 4-flute end mill. Move the lens so that the tool is in view and rotate the tool until the edge is in focus. You can tell when the tool is in focus by noting when the diameter of the tool is at its largest and the edge of the tool profile is well defined. Once that is done, tie in both the axis locks. Now there are multiple ways that you can measure this tool. You could do the previous method that I demonstrated, where I move the fixed axis crosshairs until they both intersect with the tool profile. However, instead, I'm going to use the mobile axis function. And rather than manually moving the axis to the tool, I'm going to let the presetter do it for me. Now I could just call it good and save this tool. However, because I have 4 flutes on this end mill, I want to make sure that I have the most accurate measurement possible. So I'm going to rotate the tool 360 degrees to measure each flute. And each time the presetter measures a profile with a larger height or diameter, it will move and keep the axes at that point. Now, if there's any variation in the length or diameter of these 4 flutes, I know that I've accounted for the tallest and largest flute. So now that I've rotated the tool, I'm satisfied with my tool measurement, and I'm going to click on the floppy disk to save the tool. This will open up the tool library for my machine origin. In the ID field, you can enter in the tool or holder ID. This holder is marked Weldon 6. Next, I'm going to enter in the tool number. I know that this is tool number 1 in my program, so it is good as is. But I could change it here if needed, or here as well in the section where I cover how to manage work groups later on. And lastly, I'm going to enter in the name of my tool, 0.75 4-flute flat end mill. I'm going to click the green button, and now that tool is saved to the tool library. For now, I'm just going to set it aside in my tool cart while I measure other tools. The next tool I'm going to measure is the center or combination drill. Same as before, I'm going to position the lens and rotate the tool until the edge is in focus. Since this is a drill, I only really care about the Z height of my tool. So I could click on the mobile axis again and toggle the PZ measurement button to measure the end of my tool. However, I'm going to be using this drill as a countersink, and I want to make sure that the countersink is set to a specific size. Now, I could do some math to figure out how much to drill down from the end of my tool, but instead I'm just going to set my tool height at that desired diameter. To do that, I'm going to select the center measurement function. I'm going to first move the x-axis until I get to my desired diameter, and then move the z-axis until it intersects with the edge of the drill. You'll want to look for the point that both the x and z arrows are green. Once you've gotten to that point, click on the floppy disk and select New Tool. This will open up the same fields as before, where I'll enter in the holder ID, tool number, and tool description. With those done, I'm going to click on the green check mark to save my tool and set it aside for the time being. Now I've got a few more tools to measure, so enjoy this quick 10-second montage of me measuring tools. Okay, so that wasn't 10 seconds, but I had to stop real quick to show you a cool feature that you can use. I'm currently measuring this dovetail cutter, and I wanted to measure the diameter of the shaft of the cutter. Because I'm lazy, I want to use the mobile axis to measure it. However, since the diameter of the cutter is larger than the end of the shaft, the mobile axis only measures that larger diameter. To fix this, I'm going to click on the R.O.I button, which stands for the region of interest. Before I do, notice that there is a large red square that goes around the screen. This is the default region of interest, which is 5 millimeters. When I click on the R.O.I button, I can create a new region by clicking and dragging on the screen where you want the region to be. Because I just want to measure the shaft, I'm going to create my new R.O.I over just the shaft. Now, when I click on the mobile axis again, it will measure the shaft and ignore the larger dovetail diameter. Then, when I'm done, I just click the R.O.I button twice to reset it back to its default. Okay, now I'm going to finish up the rest of these tools. Okay, so while I was measuring my tools, I noticed that one of the inserts on the shell mill was chipped when I was picking it up from the cart. So I'm going to swap out that insert with a new one and remeasure the tool. However, before I do that, I want to double check and make sure that none of my other inserts are chipped. In the top left corner of the screen, I'm going to click on the icon of a sun, which will change the display type and turn the camera on so I can inspect the inserts. Off the bat, it's a little dark and I can't really see the inserts fully, but I can move the slider on the right up and down to adjust the light level. Now that's a lot better and I can see my chipped insert. I'm going to quickly mark it and then look at the rest of the inserts. The rest of the inserts look good, so I'm going to swap out this insert real quick and then throw it back on the presetter. Okay, so I'm going to remeasure this tool, but you'll notice that due to the size of the insert, I can't measure both the X and Z axis at the same time. So I'm going to measure them separately. I'm going to begin by measuring X using the mobile axis and the PX function, rotating my tool so that I get the largest value for my diameter. Once I've done that, I'm going to click on the value in the X-axis readout. You'll notice that it turned from yellow to red. This lets me know that I locked that value, and now I can move my lens to measure Z without losing my X measurement. I'm now going to move my lens to the top of the tool and click on the PZ function to measure my Z height. So now I've got both my X and Z measurement for my tool, so I'm going to go down towards the bottom of the screen and make sure that the face mill is selected as my tool. If not, I can click on whatever tool is there and open up my tool library and select the 2-inch shell mill. Now I can click on the floppy disk and select Refresh Tool. This will update the tool geometry without changing any of the information I entered in earlier. And with that, now I've got all my tools measured. The features I've just described cover most all that you need to know in order to measure tools. But as you could probably tell, I've only covered a fraction of the available features. So I'm going to quickly go over all the measurement and inspection features that come with the presetter. So let's get into it. I covered the PX and PZ functions earlier, but I'll review them real quick. PX and PZ are fairly self-explanatory, as PX measures only the X-axis and PZ measures only the Z-axis. Auto and PX-PZ are the same as they measure both the X and Z axes. If either of these is selected and only one axis is being measured, it is most likely due to either the tool being out of focus or there not being a diameter or tool top to measure. Simply rotate or move the tool to solve this issue. Moving on to the other features, let's start with the 5 intersecting line functions. There are L1PX, L2PX, L1PZ, L2PZ, and L1L2. L1 stands for the best fit x-axis line, and L2 stands for the best fit z-axis line. Each of these buttons measure a different combination of the best fit x or z-axis line with the z-axis, x-axis, or both intersecting with one another. The point that they intersect is displayed in the x and z readouts. The line function creates a line between 2 points on screen. With the magnet button turned on, clicking near the edge of the tool profile will snap that point to that edge. Otherwise, the point will remain where it is clicked. Simply create 2 points and the presetter will make the line between them and display the line information in the bottom right corner of the screen. The alpha-beta function measures the angles between 2 intersecting lines. Create the first line by selecting at least 2 points. You can add more points if you would like to refine the line further. Next, select New Line and create the second line using the same method as the first. Once created, click on Select Angle. Now you can click anywhere on screen and the presetter will let you know what the angle between the 2 intersecting lines is at that point. Alpha-beta set automatically creates 2 perpendicular lines that intersect one another at the center of the axis crosshairs. You can manually rotate or set the angle you want the lines rotated to in order to check how accurate the angle is on the tool profile. The Line 90-degree function requires that you create a line by clicking on the screen at 2 points. You will then need to select a third point and it will create a perpendicular line from the point to that line you created with all the information on that line displayed in the bottom right corner of the screen. R measures the radius of your tool. Select 3 points along the tool profile to create a circle, and then you can view all the radius information in the bottom right corner. R set is used to compare your tool profile to a radius of known size. So if I have a 1/4 inch ball end mill, I can enter in the tool radius of 0.125, enter in a bilateral tolerance of 2 thou, and drag my tool over the profile to see if it is in tolerance. I can also click on the lock button to keep the tolerance bands locked to the center axis. The profile function is used to create a profile for your tool and has the ability to hold 7 unique profiles for each tool. You can save these profiles to reference later on if needed. Lastly, the ghost function creates an image of the largest profile of the tool, which becomes transparent after the tool is moved. This image is updated each time a larger tool profile occurs. To view this image, click the green check mark on the top left corner of the screen. You can now use any of the previous measurement functions I just described to measure the tool. Select the green check mark again to reset the ghost profile and return to the active display of the tool. Now that I'm done measuring my tools, I want to make sure that I distinguish these tools from any other tools that I may add to my tool library for this machine origin in the future. The way I do that is to create a work group. I do that by clicking on the icon with a tool on it and selecting Manage Work Group. In the new window, click on the green plus sign to create a new work group and enter in the name. I'll be using these tools to make 95-0028, but just the Op1. Next, I'm going to select the right pad and paper to edit and add tools to the workgroup tool list. All of the tools in the tool library for my origin come up on the left side of the screen, and I can add tools to my workgroup by either double-clicking on them or using the right arrow on the bottom of the screen. If for whatever reason I need to remove the tool from that list, I can select the tool from the list on the right side and select the left arrow to remove it. Once I've got the tool list for my workgroup created, while I'm still in edit mode, I can change the tool numbers if needed by clicking on the tool and typing in the new tool number. With all my tools squared away, I can save my tool group by clicking on the green check mark. I can then make other workgroups if needed. Now that all my tools are set up and my workgroup is created, I can now export my tool offsets. I do this by opening up the Workgroups window, selecting the workgroup I created earlier, and clicking the Export button in the top right corner of the screen. This will automatically cause the tool list to pop up with a field next to each tool, which tells the presetter whether to export the tool or not. When true, the tool will be exported. When false, the tool will not be exported. For convenience, you can select all tools as true or select all tools as false using the buttons at the bottom. Since I want all of these tools to be exported, I'm going to select all tools and then click the green check mark. This will open up the post-processor window, and from here you can type in the file name for the offset file. You can then click on the floppy disk to save the file to your USB and close the post-processor. It is important that you close the post-processor before removing your USB, as otherwise the file will not save properly. If for whatever reason you wanted to quickly export tools without creating a workgroup, when you click on the tool icon, select Fast Export instead of Manage Workgroup, and this will pull up the tool library for the origin. You can then select the tool or tools that you would like to export and click the green check mark to confirm your selection. It will then open up the post-processor, and you can save the offset file using the same method I described before. Now, the method I just described will work for all Haas machines and is the most general way to export files. However, there is another way to get the tool measurements from the presetter to the machine, and all it requires is one of these and one of these. Every presetter comes standard with a label printer that you can use to store the tool information to scan into the control of the machine. There are two different methods of doing this. First, there is quick printing labels. When measuring a tool, rather than saving the tool to the tool library, you can print a label with all the tool information instead. To do this, enter in information in the 3 empty fields on the top right of your screen. In the top field, enter in the serial number or holder ID for the tool. You can also leave this blank if neither of these apply. Next, enter in the tool number, and finally, the name and description for the tool. Once these fields have been filled out, click on the label printer to print the label. The presetter will take the values you measured and the information you entered in the 3 fields to complete the label. The second method is printing labels straight from your tool library. When you open up your tool library, select the tool that you would like to export and then click on the label button to print the label. Now, you can just attach these labels to your tool and then you're good to go. So I've got all my tools squared away and I've done everything I needed to do on the presetter. Now I'm going to load the offsets into the control, and I'm going to begin by using the USB. Enter the USB into the control and open the offsets page. Press Alt to open up the presetter menu and select Tool Wizard. From here, find and select the correct offset file. It will have a .ofs file extension. The tool offset will now be updated to the offsets page. At this point, you can follow the message prompts to cycle through and change tools until each tool is loaded into the machine. Now we're going to load all of our tools using the scanner. As before, begin by opening the offsets page and pressing Alt to open the presetter menu. Unlike before, however, we are going to select Tool Scan Wizard. At this point, you are asked whether you would like to scan or merge, or scan and reset. Scan and merge is beneficial when replacing the same tool as you had in that pocket, as it will save the existing data, such as coolant position and tool type, and just update the tool geometry. Scan and reset will clear all fields and just import the tool geometry. So this is the best option when swapping 2 completely different tools. Once you determine how you would like to scan the tool, you can scan the barcode using the scan gun provided. Once scanned, if the tool number of the tool matches the one in the spindle, the offsets will automatically be uploaded. Otherwise, you will be asked if you would like to load offsets and change tools, or load into offsets only. These are fairly self-explanatory, as selecting Load Offsets and Change Tools will command a tool change in the machine to whatever tool number is on the tool you scanned. It will then upload the tool data to the Offsets page. Conversely, Load into Offsets Only will upload the tool offset for the scanned tool into the Offsets page without requiring a tool change. Then you can repeat this process for however many tools you need to upload. Alright, so that was a lot, but we're finally done. Those are all the steps that you need to know in order to get you going. This process is simple and intuitive, and we have many resources to help you be as productive as possible, including on the unit itself. On the top of the screen, click on the Help Video icon to open up our library of videos aimed at helping you better use your presetter. If you don't own an HTS400, I highly encourage you to check it out on HaasTooling.com to see if it's a good fit for your shop. If you already own an HTS400, let us know about it in the comments below. Thanks for watching, and we'll see you next time. Before you guys go anywhere, real quick, I want to talk about label holders. Now, when I was doing research for this video, I wanted to see what label holders were out there, and the most common one I found were going to be these lay flat ones. This one's from AccuPro, which I found on MSC. Now, while these are okay, I wanted to do something that was a little bit different. So I went ahead and modeled and 3D printed my own, which are the ones that you see throughout my video. Now, I really enjoyed using these, so I wanted to make them available for everyone to use. So if you go down in the description, you're going to find a bonus content link. Now, if you follow that link, you'll be able to download the STL file for the model I created, so you can 3D print your own. So with that said, I hope you enjoyed this video, and as always, I'll see you next time.